All right, so here we have partial fractions part 2. So in part 1, I would have left you with this kind of problem. Maybe not this exact problem, but one like this, where we have distinct linear factors, like this thing x squared minus 81, the denominator of what we start with, can be factored into x plus 9 times x minus 9. Those are distinct linear factors, and we can break that apart into these, all right, which would add back together to give us that, all right. Now, in part 2 here, I need to talk about the case where these aren't distinct linear factors, okay? And as a disclaimer, there are lots of different cases of partial fraction decomposition in our class. We're not going to look at every single one of them, but in a calculus textbook, you'll see a fairly big table of all the possibilities that you could encounter of partial fractions, okay? So this one here, this problem I want to do now, 9 minus x squared over x times 5x squared plus 1, has an irreducible quadratic factor. And what I mean is 5x squared plus 1, I can't factor that any further into something simpler. And it's quadratic in that its highest exponent is a 2, all right? So it's irreducible since I can't factor it any further, say, into linear factors, and it's quadratic because of the square. All right, now if you had an irreducible quadratic factor, it takes this form right here in the decomposition, all right? Now, I think that this should still seem conceivable to you. Could it be that these two fractions add together to give this one? I think that it sure seems like it could be, because what's the common denominator between these? It would be x times 5x squared plus 1. All right. So it's conceivable that you could add these and get that, or that you could take this and break it down into those. Okay. So what we do when we have partial fraction decomposition is the reverse of adding fractions together. All right, what would surprise you about this is that that needs to be bx plus c up there. That's probably the part that would surprise you, but I'm here to tell you that it needs to be that way, all right? Okay, so there, you start with that. You may not have known that it needed to be this way, but this is how it needs to be when we have an irreducible quadratic factor. Okay, so let's just take this as our starting point. Now, we still find a, b, and c, these constants, the same way as other problems. If I add these together, I need to be able to get this. That's the key to finding out what a, b, and c are. Okay? So, well, how would we do that? Common denominator is x times 5x squared plus 1. I multiply this by 5x squared plus 1, and I multiplied this one by x. All right? So here's the way that would work out. I get 9 minus x squared equals a times 5x squared plus 1 plus bx plus c times x. All right? You might say, where are the denominators? Well, they don't give us any extra information. If I take this fraction, a over x, and multiply top and bottom by 5x squared plus 1, I will get that on top. And if I take this one and multiply top and bottom by x, then I will get this. And it will be over the common denominator, just like this one is. But for these to be equal, what I get up here needs to be equal to what I have over here. Okay? So this is all that you're going to get. All right? Okay. Now, I think that this should all be multiplied out. We should combine all the like terms that can be combined, and so on. All right? So here goes. Let's just carry this 9x squared. All right? And we got a cat here. All right. Okay. And then we'll multiply through. We'll say 5ax squared. That's this part. Plus a, right? And then here we'll get bx squared and plus cx. All right. Okay, so I have that. I'll combine my like terms. Okay, so let's see. These have x squared in them. So let's do 5ax squared plus bx squared. Okay, I'm having problems with the cat. Hold on. All right. So those are like terms. So I'll group those together. Then I get c times x, and then I get a. And so it's like there they are in order. Now about this, I'd like to combine these. And by combining them, that will be factoring out the x squared. So let's do this. Let's say we'll get 5a plus b x squared, where we could remultiply and get right back where we started, so this is valid to do that, plus cx plus a. Okay, now I need to make this be equal to that, and they don't really look the same, so I think we should start by making them look the same. Okay, here's what I mean by that. With this, I notice there's a x squared term, there's a term with x, and then there's a term that's a constant. Okay, a, b, and c are constant. So x squared, x constant. Why don't we rearrange this so that it's also like that? So like I got -1 x squared, for example. I don't have a term with an x in it, so I'll say plus 0x. I do have a term that's constant, so I'll say plus 9. All right? And so that now looks a little bit more compatible with what I have over here, right? Because I got 5a plus b. That's the coefficient of x squared. I get that constant, whatever it is, times x squared, plus cx plus a. All right, now that and that have to be the same. How is this, how's a, b, and c going to be such that this and this are the same? Well, this number, this coefficient of x squared, it's going to have to be what? I guess the -1, right? That's going to have to be negative x squared if it's going to match this. That c right there, it's going to have to be that number. It's going to have to be a 0 because there isn't an x. There's an x squared and a 9, but there isn't an x. And then this a is going to have to be 9, right? That's the only way it's all going to match up. So, all right, what does that become? That becomes linear equations. I get one at a time. 5a plus b has to be this number, -1. C has to be this number, 0. And then A has to be that number, 9. Okay? So I've got two of my answers right away. C is 0, A is 9. By substitution of A, I can find B pretty quickly. All right? So let's do our substitution that we know A is 9 already. 5 times A, that's going to be 45. And then I get plus B is -1. So that makes B equal to -46. All right. So I have all my information then at this point. I've got A, I got B, I got C. That's my breakdown here. All right? Okay. That's how we need to work this one. Remember, the idea with partial fractions is I don't have a way to work this as it is. But I take this, I break it down into these simpler, smaller parts, and then I have something that is hopefully easier to work with. Okay? So I'm going to use this now up in my integration, given that I know what A, B, and C are. All right. So you saw my answers down there at the bottom of the page for A, B, and C. So here's, it's A over X. All right, so A turned out to be, that was 9. So 9 over X, and plus BX plus C. So I got B to be -46, and C to be 0. So BX plus C is -46X. So let's do like this. Let's do -46 and just put X like that. All right, over 5X squared plus 1. All right, so there's my problem at this point. Now, hopefully these are easier to deal with than that. I hate to do all this work, and then I still can't solve the problem. 9 over x, that will be pretty easy to do. What about 46x over 5x squared plus 1? How are we going to do that? Do you recognize that as being a specific problem type? So let's do this. Let's do this. So I don't want to do a bunch of work up here. I'd rather work that one out separately and just carry my answer over. So suppose you had just, 46x over 5x squared plus 1 dx. What kind of problem would that be? Seems like it could be u substitution. If I let u be 5x squared plus 1, then the du would be 10x dx. I got 46x dx, but that shouldn't be a problem. I can make that work. All right? So yes, this one is u substitution. I'll let u be 5x squared plus 1. As a result, du will be 10x dx. Suppose that I'd like to substitute the x dx. All right? Then I'll solve du over 10, and that will be x dx. Okay? So I get this, I get a place for this. I substitute the variable x away, I introduce a new variable u in du. Okay? But that's how u substitution works. By now, if you're in Calculus 2, you've done lots of u substitution. All right. But I got this number 46. X dx, that will be du over 10. Okay? And then 5x squared plus 1, that will be u. Okay? So numbers, I get 46 over 10, which I can reduce that, but I'm not really worried about it at this point. And then that's the form I was looking for, something I recognized. So that's going to be 46 over 10 natural log absolute value of u plus c. Right? Okay, so that's what we are hoping for, something like that. One more thing. So this will be 23 over 5 if reduced. Natural log all along u is 5x squared plus 1. And I guess I don't really have to put the absolute value, because 5x squared plus 1, that's going to be a positive number. But I'll leave it. I'll leave it as 5x squared plus 1 absolute value. Okay, now so I got that one. U substitution is what I needed. More importantly, I would need to recognize that that part is U substitution. All right, so here's our answer then. 9 over x, that will just be 9 natural log absolute value of x minus, and this one we did on scratch paper. Okay, so we got 23 fifths natural log absolute value 5x squared plus 1 plus c. Okay. And so now we're done with it. All right, so you saw the whole problem start to finish. There's one thing that I would like to show you now that I'm done with it that I didn't show you right here. Okay? Now, for me, you can do some of this in your head. You don't have to do each and every step. Okay? Most of this I could do in my head. Maybe you could also. And I'm not bragging about that. I'm just saying it's true. I don't need to write a lot of it down. I've done it before. I know how it's going to work every single time. But I would like to provide a little bridge right here. And if you don't need this part, that's fine. You saw the part you needed, so that's okay. But remember, if I'm adding these together and I'm going to say it's equal to that, the way that I do it is like this. I take this fraction, a over x. I have to multiply it by 5x squared plus 1 in order to get what I see as the common denominator between these two fractions, which is x times 5x squared plus 1. I need to take this other one, bx plus c over 5x squared plus 1, and I need to multiply top and bottom of it by x. All right? So, okay, let's say that we're going to put like this, we're going to put like this, we're going to multiply by x over x to get the common denominator, 5x squared plus 1 times x. There they are. Now, add these together, it's going to be this top part over the common denominator. Here is that top part, all right? Right here. So I jumped over this, okay? Because I'm thinking that you're in calculus too, you know how to add fractions. If it helps you to see that, if you like to be more meticulous, that's the step that should be there, okay? But I'll leave it up to you if you feel like you need to write that.